mean, how many times do I keep referring to freshman algebra? All the time. The algebra needed to solve trig equations include the standard operations of collecting like terms. You know how to do that. Factoring, I would hope you know how to do that. Setting factors to 0 and solving for x. All right, just look up here. I don't even care if you write this down. Just watch. If I told you to solve this linear, question of the day. Why is that a linear equation? I'm going to kill you. Why is that a linear equation? You guys that didn't have me 2 years ago are excused. Doubts?
All the variables in the problem are to the first power.
All the variables are to the first power. So that's linear. How do you solve linear equations? Are you kidding me? Algebra isn't any simpler than that. Variables left, constants right, get your answer, right? If you go variables left, you get 2x. If you count constants right, then you would divide and you would get your answer. You don't have to write that down. Look at this. See how those are already factored, set to 0? How would you finish solving that equation from freshman algebra? Oh boy, this is what's going to happen today in the trig. But first, I'm going to show you the algebra. Oh wow, you see how I already have it factored there for you, and it's set to 0. So you got 2 factors set to 0. What does that mean? Ooh, this is not good. Quinn.
Do you take each set of parentheses and set it to 0?
Yeah. Remember you set each one to 0, like this? I'm sure you remember it now. You just set each factor to 0, and then you just solve. Okay, that was pretty easy, right? That's just freshman algebra. This is going to be trig equations now. So, let's do this right away. In your notebook. Now, you're gonna need a little space. I want you to mark down right now A, B, C, D, and E. They're up there on the board. Leave yourself room for the work. Do that right now. Then it'll be easier when I start going through this. Go ahead, get them spaced out. A, B, C, D, and E. These are trigonometric equations. Trigonometric equations. And today, all I'm doing, this ain't gonna take me the whole period, all I'm doing today is going to solve trig equations that are linear. That would be the easiest kind. Trig equations that are linear. Now, you might want to, remember that nice chart I gave you about a week ago with all the answers on it? If you have that in your notebook right there, you might want to take that out. It's going to help you. I hope you still have that. Remember I gave you that nice filled out chart with everything on it? If you have that there in your notebook, you might want to have that out next to you. Keep writing those down, and I want you to listen to what the directions are going to be here. Write them down already? No. Over there.
Okay.
Not that stuff in the column. That's not for you. Going across the top there. With the trig stuff in it.
You just want to start them next to each other?
However you want to stretch it out. directions are going to say, and now you're going to look on the handout again here. See the note? You will be asked to solve trig equations over a now pay attention to this, over a restricted interval, such as, now, can one of you tell me what that means there, what I have there? See those intervals I have written there? What's that mean? See on the paper, I said over a restricted interval. You see the first one says bracket 0, comma 2 pi parenthesis, and the second one says bracket 0 degrees, comma 360 parenthesis. What's that mean? Because you've seen that before. Damn, you guys forget stuff so fast. Jimmy.
There's a point at 0 and it goes all the way past. It's like an arrow past 2 pi.
What's one revolution?
2 pi.
In radians. In degrees, it's
360.
okay. Now, you know what? Because there's two ways you can do this. What I'm going to decide to do, because it'll be easier for you, when you write all your answers, you're going to write them all in degrees. And I know you would rather do that anyway than radians. So you see where it says 0 to 2 pi on that study sheet? Put an X through that. Just put an X through it. We're going to do it in degrees. Just put an X where you see the 0 to 2 pi. So this, right here, doesn't this mean an angle from 0 to 360? Going around. Now, you're gonna want to write this down. 30 degrees, 45, you somewhere off to the side, away from those examples. Okay. I would hope you're going to be able to tell me this. I would like somebody, look, to go around the horn there, 360 degrees. If it's 30 degrees in quadrant 1, what's the angle in quadrant 2? What's the angle in quadrant 3? What's the angle in quadrant 4? That's 30 degrees away from the x-axis. Understand what I just said? If it's 30 degrees in quadrant 1, what's that angle in quadrant 2? 30 degrees away. So you guys should already know all this. Nick.
30, 150. Oh, wait. Am I doing 45 now? Oh, no.
Oh.
30.
What is it in the third?
210. And then 330.
Write these down. You're going to see why here shortly. Okay, if it's 45 degrees in the first quadrant, go all the way around the horn and tell me what the angles would be in the other 3 quadrants that are 45 degrees away. Make sure you're writing this down. Jack.
135, 225, and 315.
60 degrees, what would it be? Let's go all the way around the horn. What would it be? Dave?
Would it be 120,
Yeah.
40, and 300?
You all know what I'm saying. Okay, here we go. The directions are going to say solve each equation in that interval. What if it didn't say that? Couldn't you keep, remember coterminal angles? Go around, go around, go around. No, we're not going to do that. There'd be infinitely many answers. Directions are always going to say, it's one time around. What are the answers? Now you see those 5 problems over there? See the theta? See the x? See the theta? What do those stand for? Think of what? thetas and the x's that you see in those equations, what do they represent? A what? Easy question.
An angle.
And they're all going to be special. You got to know your values. Are those all linear? Why? Look at them. Those are all linear trig equations. Why? They're the easiest kind you'll ever see. Wrong. Right, there's no sine squareds or cosine squareds or tan squareds. They're all linear. Tomorrow I'll show you quadratic. How do you solve linear equations? Variables left, constants right. Just like I was doing here. So right here, you see this little one here? You don't have to do this, but if you solve this, wouldn't you just, right? That's algebra. Solve this trig equation. What are you going to do first? Now do the same thing you would do in algebra, but you got trig up there. Come on, it's an easy one. Solve for theta. You can't solve for theta till you solve for sine of theta. Then it's just special angles. These are going to make this difficult. This is not that hard. Variables left, constants right. Just give me the next line of work here. Max.
2 sine theta equals 1.
And what do you got to do to both sides? Divide by 2, right? So sine of theta equals 1/2. Oh, you see, you'll get the hang of this in a few minutes here. Now you're just going to tell me what theta is. Now listen to me. This is big. Look. See this? You're only going around one time. And all these problems we're going to do the rest of the week. What quadrants are you in? You see this stuff with the quadrants? It never goes away. You should have that memorized by now. If the sine of theta equals positive 1/2, where could the answer be? Come on, you guys forget stuff way too fast. That's why some of you are going down in this class. Some of your grades are going backwards in this class. Chris. 1, 1 and 2, right? What's the angle for theta that equals 1/2? You should have that memorized. You shouldn't have to look at a frickin' chart. I'm serious. You guys, some of you rely too much on that. The sine of 30 has been, well, 30 is the answer. But the sine of 30 has been 1/2 forever. So this equation has 2 answers. What are they? See why I did this now? There's always a reason why I do this stuff. Howard,
30 degrees and 50 degrees.
you see how you're going to write it? Look, just going to write it like that. 30, just put a comma. There's more than one answer there. Yes?
So we'll always do quadrant 1 since they're always positive, and then whatever other quadrant is positive, they would go on.
Yes. Or it could be negative too. Don't rule that out.
Oh, there will be a
Well, it
negative.
could be.
Okay.
Watch. Look at this one. That's a pretty easy one. What are you going to do first here? Variables left, constant right. Just like algebra. Isn't this minus sine of x going to come over here and become sine of x?
You see Mr. Saitak? I don't know, is this his off period?
It is.
Alright,
He's up in the teacher's room.
alright, I left my jacket
Go.
in
Okay.
his room. Will you ask him for it? 'Cause
Sure.
I'm sure he has it. I'll grab it from you at the end of the day.
No
Thank
problem.
you.
This comes over here, what are you going to have? Guys, just like I did here. This comes over here, that was 2x. So if you take the minus sine of x and bring it over, there's already a sine of x. What do you have all together? Ethan.
2 sine x equals negative radical
2 sine of x equals negative radical 2. You with me? Stop me now if you have a question. But today's class, these are the easiest ones. And then, what are you going to do to both sides? You're solving a regular linear equation just like you did in algebra. Oh, fellas, come on. This isn't that hard. What are you going to do to both sides? So you just have sine of x there. Rob, divide by 2. Now, Socko, this is exactly what you were just asking me. This says the sine of something equals negative radical 2 over 2. Well, an angle won't be in the first here, because that's negative. What's the reference angle, though? You got to know that first. What's the angle that equals radical 2 over 2 for special angles? You should already know that. You shouldn't have to look at a chart.
135.
No, what's the reference angle, I said?
45.
45, right? What quadrants can the sign be negative? What quadrants?
3 and 4.
3 and 4. Are you with me? So what are the two angles? Again, see why I did that? You see, you can appreciate why I did that now, right? Give me the two answers. What are they? Ethan.
Negative 225, negative.
No, they're not going to be negative. None of these answers will be negative.
It's just 225.
225, and what else?
315.
315. Do you see that? There's the first two examples. I mean, by the time I get down here, you should be fine. Who has a question? Are you sure? Today's homework will be the easiest kind, because they're just linear. What are you going to do here? Solve. Somebody. You should already be getting the hang of what I'm doing. It's freshman algebra, linear equations, using trig. That's what today is. Andrew.
Maybe sine of x equals 1.
Now, hold up for a second, Andrew. What about this one? It's not any of those. You should already know this. This is saying the sine of what angle equals a 1. What kind of angles does this apply to? John. See that unit circle stuff, right? Quadrant angles? What's the angle? The sine of what angle is a 1? 90. 'Cause at 90, what's the point up there? 0, 1? Isn't the sine the y coordinate? The stuff you've been learning all year, it's still there. X equals 90 degrees. There's only one answer there. What are you going to do here? Solve. We're almost done here. You're going to do a lot of this in class today. What are you going to do here? Solve for x. Jake, what are you going to do? It's going to be the first step. Put the 1 on the other side. So you got 2 cotan of x equals what, Jacob? Negative 2. Now what are you going to do? So cotan of x equals negative 1. It's negative. So before you can give me the answers, you got to know what the reference angle is first. What's the angle for cotan that has a value of 1? Yeah, what do you got there? He is here. You can just get a pen and pencil and put this. Yes, he's here. Alice, you've got to know. I'm getting it. It's like it's a broken record. You got to know your special angles. If you know your special angles, this ain't hard. What's the angle for cotan? Actually, it's the same for tan, too. What's the angle for tan or cotan that has a value of 1? 45, right? Isn't the tan and cotan of 45 1? But this says negative 1. What quadrants is that answer going to be in there? Where's cotan negative? What quadrants? Rob? 2 or 4, right? So, give them to me. Those are the answers. Now, 45 is your reference angle. That's all you need to know. That's why I wrote all those over there. Rob?
135.
Who has a question? See, some of you are going to sit there and somebody might say, well, what if it's not a special angle? For now, it's going to be. I'll show you later on what to do when it's not. We ain't there yet. They're all going to come out to be those kind of angles here or the 0, the 90, the 180, or the 270. The one's right on. Those are going to be all your answers. What do you do with this thing? Isn't this like that from freshman algebra? See why I showed you that? What are you going to do? Same as 9th grade algebra. Here's a factor times a factor set to 0. What do you do? It's the same thing. What do you do, someone? What do you do, Max?
Break it into 2 and then
Set each one to 0. So go in your notebook. 2 cosine of theta minus the square root of 3 equals 0. Or, put the word or there, or tan of theta plus the radical 3 equals 0. So when you have 2 factors multiplied set to 0, you set each to 0, and now, what are you going to do here? Variables left, constants right. Variables left, constants right. All right, let's do this one. Somebody, I want you to tell me. Right here. What are you going to do first? Variables left, constants right. Come on, these are not that hard. Tell me what the right here. Variables left, constants right. Right here. Jack.
2 cosine theta equals square root of 2.
Okay. And what are you going to do to both sides?
That's it.
Cosine of theta equals radical 3 over 2. Okay. Now, Sokka, I'm going to come back to your previous questions. Whenever this is positive, the one answer is always going to be in 1, of course. But there's going to be another quadrant, too. Question. In what quadrants are you in here for the cosine of theta equaling a positive radical 3 over 2? What quadrants? Noah? 1 or 4, right? What's the angle that has that value for cosine? What's the angle? What's the Andrew?
45.
No. No, it's not 45. Check your chart there. What angle? Yeah.
60.
Cosine of 60? Is that right?
No.
30. Got to know your angles. So this is 30 degrees, or what's the other one going to be? What did you tell me? Somebody told me 1 or 4, right? So 30, and what's the one on the fourth then? That's why I wrote all those. Rob? 330. Now, let me get something out of your head. Some of you might be sitting there going, are you ever going to have negative angles when you do these? No. Are you hearing me? No, never. Never, never, never. All the angles will just be going one time around in one of the quadrants. No, you will not have negative angles. And what about this? Tan of theta equals negative radical 3. What quadrants first? Where can tan be negative? That's where your answers are going to be. Max?
2, 3.
No, tan's positive in 3.
2 and 4.
2 and 4, right? Now, you can't give me the answers until you give me what's the reference angle that goes with square root of 3 for tangent. You have that chart there? What's the angle? Adam? 60. So if it's 60 degrees for the reference angle, I'll just put it there. Okay, now give me the answers, though. Where are the answers? What did you tell me? 2 and 4, right? Well, give them to me. What are they? What is it in a second? 60 degrees away. What is it in a fourth? 60 degrees away. Quinn?
120.
120
and 300.
and 300. Now, do you appreciate whenever I give you this test? Pay attention. When you get to the test, you know, so many points, so many points, so many points, so many points. You're all worth so many points. Some of these are going to have like 4 answers to them. Some of them might have more than 4 answers to them. Take your iPads out right now. Take your iPads out. Hope you guys are paying attention. It's so easy when I grade your test papers to see who's been doing what they're supposed to and who's not. It all comes out in the wash at the end. You gotta know your special angles. Go to page 254. Take out a good sheet of paper. Go to page 254. Well, you know what? Here, just do this. There's two more you gotta add. See at the bottom of the handout? See where it says 11 to 14? Look, don't forget this. See at the bottom it says 11 to 14, 17 and 18? Add 23 and 24 to this. Write it right at the bottom of the handout. Right at the bottom it says page 254, do problems 11 to 14, 17 and 18, add 23 and 24 to that also. Now go to your textbook. I want you to see this. You're going to start doing this right now. Go to your textbook. And if you glance at these problems, these are going to be linear trig equations. 4, 5, 6. Fellas, there's only 8 problems here. So, all right. Do not do anything else. I actually want these on my desk before